This is our third video on functions, so we're going to talk about some more advanced ways to work with functions. So just to review, in the first video, we talked about using built-in functions, primarily from the C Math library. In the second video, we talked about creating our own functions, and we created two varieties. The void functions, which don't return anything, typically will print something, and then the value returning functions, which actually return some value. Okay. So we're now going to look at an example. So I guess all the examples that we've done so far have defaulted to pass by value, okay, which means the parameters we pass, we don't pass the actual variable address. We just pass what's currently in that variable, okay, what's stored there, okay? So here's an example of what we've been doing so far. I've got this function f1. It returns an integer. It takes two integers x and y. Okay. And then it calculates an int s as x plus y. It's then going to reassign x and y to be 100 each. It's then going to return that value of s. Okay. So down in our main program, we're setting x to 10 and y to 10. We're calling the function s on f1, calling the f1 function, setting it x and y. Then we're going to print out that x plus y is equal to s. Okay. So I wanted to take a look here at what's going on in memory. We've avoided this so far, but one of the differences between C++ and Python is that C++ allows us direct memory access, okay, which is a new thing for us, okay? So this is a representation of what happens. When you do the dot slash your file name.exe, the operating system is going to set aside a contiguous block of memory for your program to execute. Okay. And that's what I've got in the bigger rectangle here. Okay. Then since your program has a main, int main, okay, as the first function that runs, if any executable C++ program has it, it's going to set aside a sub block of that memory for main. Okay. Inside of that, we can define variables. And remember, a variable is basically a label for a memory address. So let's assume that X is in this 1101 memory address. In reality, it'd be a lot longer than that, but that's the basic idea. Okay. And then we can put a value inside of X, whatever that is. Okay. So now when we go to call the function, okay, so let me copy this. It's going to stop what it's doing in main, okay, and it's going to create another memory block. Okay, so from our example we're doing, now our example had two variables, so we're keeping one just to keep it simple. So this is going to be the memory for F1. Okay, so now we're in the memory for F1. And there's an X and a Y in our example. There should be both. We're just doing the X. Okay. So I can call this X if I want. I don't have to. I can call it whatever you want. It's a positional thing. Okay. But this X will have a different memory address. Okay. It's not physically the same. Okay. So what we're doing here in essence is we're going to be sending the value. Okay. So the value from here, what's in this box, is going to come up into this value. Okay. So that's what's happening when we pass by value. So whatever we do to X, whatever changes we make in here, we don't worry about, right? They're not going to be real. Okay. They're only temporary. So they're real only within here. As soon as we hit a return statement, so as soon as there's a return, then we're going to get back to here, find my cursor. I was moving it. Well, we'll get there. There must have been an easier way to do that, but I did it the long way. Sorry about that. Okay, now we're back to here. Okay, so it goes back. That memory is now freed up. Okay, so that's basically how it works. Okay, so the next thing we're going to talk about is passing by reference, and we'll see how to do it in our code. But what's happening physically is we're going to create, just like we did before, when we call our new function, we're going to still call it f1. Okay, when I come up to here, it's going to allocate a new spot in memory. Okay. But instead of passing a variable, so I'm going to have to make some changes to this, going to ungroup that. So I'm going to get rid of this, get rid of those. We're not going to have that. I have a love-hate relationship with Google Draw. Okay. Okay, so we still have this idea of X, but now instead of passing along the value, when we pass by reference, what we're really doing is we're going to have a um, a link to the memory address. Okay, so what we're really sending is this. So this now points to this. Okay, and when we do that, whatever changes we make here are reflected back here. Okay, so that's kind of the point of passing by reference. Okay. For simple variable types, we have an option. We can pass by reference or not. When we get to bigger things like arrays, we're not going to have the option. They're going to pass by reference all the time. So we're going to have to take some pains when we get there. Okay. So that's what's happening in the memory. So let's go back and look at the code and how we would make this happen. Okay. So we've got our same basic program here. The differences we need to make are here. In that if we want X to be a pass by reference, I'm going to add the ampersand, the shift 7. Okay. That tells the compiler when I send X, don't send the value, send the actual memory address so that any changes I make to X will be reflected back in the main. Okay. Y is being passed normally, so nothing's going to happen there. Okay. So let's compile this and run this and see the difference. Okay. We see that the X has changed. The Y has not. Okay. And you can certainly send along both if you want. Okay. Um, I'd said in the previous video that you can only send one thing back from a function. Okay. But there's a way we can send more than one thing. So let's say we want to do the sum and we want to do um, the product equals X times Y. And I don't know if this is a great function, so I'm not sure that's something to really do, but you get the idea. Okay, so I can't return S and P, but I can make this a void function. Okay. I don't really care about X being sent, but I can include an int S as a reference value and an int P as a reference value. Okay. So now I don't return anything. And since I'm declaring them up in this line as a parameter, I don't have to declare them again. I can just do this. I can just give them values. Okay. So down here, I would have to have declared both an S and a P. Okay. And then when I call the function, I would call it with X, Y, S, and P. Okay. And again, I don't need to name them that, but I could. Okay. So again, if I'd named them and said, well, no, that's okay. Then I won't show that example, but just trust me that it's true. Okay. Then I could say multiply is equal to P. And unless I made a typo, this should work as well. Okay. And it does. Okay. So using that technique, I'm able to send back two values. Okay. The only thing to worry about there is that you have to make sure that um, that you want those side effects to actually happen. Okay. So if you send in a variable as um, as a reference variable, then any changes made are going to happen back in the main function. Okay. Um, we'll talk later. You could make it a constant reference, but at this point, there's not a reason to do that. Okay. So we'll just leave that as it is. Okay. So the next thing that we're going to talk about is the idea of creating function prototypes. Okay. We mentioned it before. The way it stands now, if I'm going to call my F1, let me see if I can go that back because I didn't want to kill it all. Yeah, we'll leave that there. If I'm going to call F1, I have to define F1 before I use it. Okay. So if I don't do that, so if I were to define it, say put my functions down here, okay, and I'm going to make it more organized. We often want to see the at main because that's where the action's happening. Okay. So let's move my function down here. Okay. Let me run it. See what happens. There's a problem. It doesn't know what F1 is. Okay. It wasn't declared in this scope. Okay. And because by the time it hits this line, it hasn't made it to here yet. Okay. So to avoid this, we want to take the following steps. And this is something we certainly want to do in our programs now. We want to do a function prototypes. Okay. Where we're just going to set, we still have to do something before it main, but we don't have to do much. We basically just have to tell it what it is that we're going to do, just the name, okay? So I can copy this and move it up to here, okay, with just a few changes. We have to have the return type, we have to have the number of variables, okay? And we put a semicolon at the end, okay? And that's it. That should fix it. And we'll have function prototypes for all the functions we're going to need. And that way we don't have to worry the order that they're done in. Okay, we do that. We do that. Works just fine. Okay. We don't need that much information. In fact, if we want, we can certainly get rid of the actual variable names. Okay, because it doesn't care about that yet. Okay. I think that that has to stay there. We'll see how that works. Yeah, we're good. Okay. You certainly can put the function or the parameter names in there if you want, but you don't have to. Okay. So again, that's a way to make your program a little bit neater and that we can get to int main a little more quickly. It also gives you, if you have a bunch of functions, they're all defined right together and you can see what's going on. Okay. And that's going to be helpful in the next thing we're going to talk about. Okay. And I think this is the last thing we're doing in this video. And that's going to be function overloading. Okay. So let's get rid of this function. I want to do something a little bit different. We can leave our X and Y. We may even need that. Okay. So let's say I'm going to create a function called Atom. Okay. It's my basic function. I'm going to start with a prototype. Okay. It's going to return an int and it's going to take an int and an int. Okay. And we can say here that this is going to return, need to make that a comment. We're going to return the sum of two ints. Okay. So I then have to define it. And what I often do, I'll do the prototype first. And then you can copy this. It's the other way around. And now to the function definitions. Remember, we have to get rid of the semicolon. We have to put in actual values. Say we're doing A and B. Okay. And all we're doing here is returning A plus B. Okay. Pretty basic. So here we have our X and our Y. So I can just, in my cout, we'll just ignore this. We'll get rid of this. Don't care about this. Instead of the S, I can say Atom X, Y. Okay, different variables, but we don't care. And in the cout, when it hits this statement, it will stop. It will fire up the atom. It will send the values of X and Y. it will get the sum, add them together, and return it back to here. Okay. 10 and 10 are not good answers when we're doing something like this because it could be that I'm getting the same value twice. So let's do it this way instead. Okay. So this should work. Our function is down here. We've got our return. We've got our names. Should be good. Let's try it and see. Okay. Nothing new here. Just making sure this is working. And we've got 10 plus 20 is equal to 30, which is correct. Okay. So this idea of overloading. So let's say we have two doubles. Okay. We have a double Z is equal to 2.5 and a double W is equal to 3.2. Okay. If I want to call the atom function on this, okay, on the Z and W, and then send those values. Okay, let's see what we get. I've typed it incorrectly. Looks okay. Okay, we get 2.5 plus 3.2 is equal to 5. And that's not correct. It's not what we're looking for because we sent it doubles. Okay. We really created an error in setting it the wrong parameter. But remember that when it can, the compiler will do an implicit typecast. Okay. It'll change the 2.5 to a 2 and a 3.2 to a 3. Okay. Um, I think it just concatenates. We can test that. What if I have a 3.7? The answer there should round up to 6, but I don't think it will. It does not. Okay. So that's a problem. Um, we've lost some data for sure. Okay. So we could, if we wanted, we could call this like atom int version. Looks like a Taylor Swift song title. Okay. And then we could come through and do an atom double version and all that. Okay. But we don't want to do that. The atom's a good enough name, but we want to be able to define a different function with the same name, okay, called function overloading. And we can do that, okay? When we do that, there's some rules. The first rule is that you have to change the function in some way that the compiler can tell it's a different function, okay? And you do that by changing the number or the type of variables, okay? So in this case, I want to return a double. I'm going to take two doubles, okay? And then, of course, I'm going to have to rewrite the function. No way around that. There is a way around that. We'll talk about that later. Okay, so I have to make this one the double version with the double A, double B. Okay. Now, if I've typed all that correctly, will be a miracle, but we have a miracle and it works. So now we get the correct answer of 6.2. Okay. So again, the way this works, I have both functions in my function prototypes. When it calls the atom, the same exact function name on X and Y, since X and Y are both integers, it calls the integer version. When I call it on Z and W, it's going to call the double version. Okay. What if I change this around and call on one int and one double? See what it does. Compile it. Nope, got a problem. Okay. Since we have two versions, before we would have been okay with just one version, but now we have specifically this version. It's not going to do the implicit typecasting on that one. Okay. So the other thing we can do, in addition to changing the type of the parameters, we can also change the number of parameters. Okay. So let's say I want to have an atom function that takes 3 for some reason. Okay. That's all I want to do. Can't paste before you copy. So let me kill it. Nope. Let me kill it. Let me yank it. Let me yank it again. Okay. This time it's going to take an int. int. Okay. Return the sum of 3. And I should have changed that to doubles. Okay. So now down here, I'll copy this one because it's closer. These can be in any order. I usually keep them in the same order as I declare them in the function prototypes, but you certainly don't have to. Okay. A, int B, int C, and then we have A plus B plus C. Okay. And then we can test this one. Just see out. We don't have 3 integers. So we can do int K is equal to 40. And then I'll just see out that result. Add them with X, Y, and K. Which should give us 40, 50, 60, 70. So we should have a random 70 at the end. Okay. Looks okay. We get our random 70 at the end. Okay. So that can be a very useful thing when you're going to want to have the same function, but with different parameters. Okay. So again, you have to have a different number of parameters or a different type of parameter. Okay. You can't just change the return type. Okay. So if I were to do something like um, double atom int, not enough. Okay. It would not work. Okay. It would give us an error. Okay. So that's function overloading, which is a useful thing that you can do. Okay. Um, so I think that is mostly what we want to talk about here. Let's see if there's anything else. Checking my notes one more time. Oh, there's one more thing. Default parameters. Okay. So let's talk about this idea about default parameters, which can be useful. Okay. So let's say we're going to create a function that it's going to be a void function. We're going to call it greet. Okay. And it's going to take a string for name. Okay. And then the function itself, again, I can copy this. Function itself will be fairly straightforward. Again, I'm going to keep it in order, but you don't have to. We're just going to say cout, hello, name. That's it. There's no return because it's a void function, and we're going to just pass along the name. We put our space in there, so we should be okay. Okay. So there are times when you want there to be a default value in case the user doesn't enter one. Okay. And they're a little bit tricky to get right, but in this case, not the syntax, but when you would use them. So we could say string name is equal to, let's say, guest. Okay. So then when we call this, let's get rid of all the printouts here because we don't care about that. Okay. So when I call it, okay, so we've got this function greet. It just takes a string. If I say greet Bob, okay, then it should say hello Bob, and it does. Okay. If I omit this, where before I put the equals guest, it would have given me an error. Now it's going to take that default value. Okay. So a place that you could use this that may be more reasonable. Let's say you don't want 2 versions of this. Okay. So the function parameters, I could say here, I think you need to put in what you're doing. So let's do int a, int b, and int c is equal to 0. Okay. So this will take um, 2 or 3 ints. Okay. Should be okay. Okay. So we're going to change. We don't need this version of Atom anymore. Okay. We're going to go with this one. And this should still be the same. This should all be fine. Okay. It just means when I call it with our ints, if I call cout Atom with A, B, C, it should give us the 70. But if I call it with just A and B, for example, it should give us 30, which is correct because it defaults to that. Okay. See if I got all that syntax correct. Doesn't like something. Oh, I didn't give the variable names correctly. Those should be X, Y, and K, oddly enough. X, Y, K, and that's just X and Y. Okay, let's try this one. Okay, run it. And you see that it correctly gives 70 in the first case and 30 in the second. Okay, so default values can add some functionality, especially when you have some kind of um, situation where you don't always have something. So sometimes there's a default value almost all the time that you can add that into your mathematical calculations or whatever. Or as we saw here, we have something that if we don't need all the parameters to be sent. Okay. So that's the basic idea here. Okay. With functions. And I think that is all. Let me check my notes one more time. Don't leave anything out. Almost left out that one. This was a long video, importantly. Okay. So default values can only be specified in the prototype or the function definition, but not both. So I'm doing it in the function prototype so I can see I could have just as easily done it in the function specification or function definition further down. Okay. So a couple of tips we have here when we're using functions, just to finish up functions, that we can use the pass by reference. If we want the mutability, we'll talk about mutability a lot. The mutability means the ability to change. Something that is mutable if you can change it. It's immutable if you can't. So if you need the ability for a variable to be changed by a function, you pass by reference. Okay. It also affords some memory savings that you're able to only have one copy of the variable. In case you're in a really restricted memory situation, you could do that. Okay. Um, if you don't want the function to modify things, then you want to pass it by value. That will keep that from happening. Okay. As far as the function prototypes go, you always want to put function prototypes. You want to use them in all of our programs from now on. You want to put them at the top of your function, so they'll be there when you need them. But use the prototype so you can get to your int main quicker, so folks can see what's happening with your code. Okay. As far as function overloading, you have to remember that they have to change in the number or type of parameters. Just changing the return type's not enough. Okay. And then when you're using default parameters, just make sure that you don't confuse or give unexpected behavior um, to your users when they're trying to use these functions. Um, that could be confusing for folks, for sure. Okay. So that's the basics of functions. Functions are super important in programming. They're really going to help us to organize our code much better. I know in the prime pyramid program that we just did, if we had the ability to create a prime is prime function, Boolean true false, we could move that whole inner loop out to a function, which makes the program flow go much better. Okay. We'll probably do that as a homework assignment. That's functions. Make sure to let me know if you have any questions.